Once again, for lesson 5.2, I'm going to break it up into two parts to make it shorter for you. So we're looking at slope and direct variation, and today we're just going to do the first of the two bullets that are in your book to write and graph direct variation equations. How is slope related to your shower? A standard shower head uses about 6 gallons of water per minute. If you graph the ordered pairs from the table, so we're looking at time and water usage, time in minutes and water usage in gallons, the slope of the line is 6. So if we look at our rise, we're going up 6 gallons of water, and run, we're going over 1 minute. So we're using another 6 gallons of water for every minute we're in the shower. So the equation y is y equals 6x. The number of gallons y depends directly, here's our keyword direct, on the amount of time in the shower, x. A direct variation equation is described by the equation in the form y equals kx, where k does not equal 0. We say that y varies directly with x, or y varies directly as x. In the equation y equals kx, k is the constant of variation. For our first example, they ask us to name the constant variation for the equation. So in the equation y equals kx, our equation is y equals 2x. K is the coefficient of x. So our coefficient of x is 2. So k equals 2. And then they ask us to find the slope of the line that passes through the pair of points. Slope is rise over run, so if we look at any 2 points on this line, the rise, it's always going up 2 every time. And the run, it's always going over 1. So our slope, which is rise over run, graphically, is always up 2 over 1, which reduces to 2. Same question for 1b, different graph. Name the constant variation. So in our y equals kx equation, we have y equals negative 4x. So we can see that k equals negative 4. And looking at our rise, this time our rise is going down 4 each time. And our run is going over 1 each time. So slope again is rise over run, or change in y over change in x is another common way it's done. So my change in y, it's going down 4 units. So it's going to be negative 4, and it went over 1. We're always moving left to right. Always, 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 because that's how we read in English. So that's how we get slope. So our slope is also negative 4. And now we're just going to graph. We know that we can always make a table of values. We already have done it that way. So if I put 0 in for x, I'm going to get 0 out for y. So the origin's on my point. If I put 1 in for x, I get 1 out for y. I think we've done this line before. 2 in for x, 2 out for y. Okay, but we also know, since the point 0, 0 works, we know what slope is now. Slope is rise over run. Now, the coefficient of x, if there's not a number written, we know the coefficient is 1. So our slope is, okay, we need to write 1 as a fraction. We can write any whole number as a fraction by putting it over 1. So this line is going to go up 1, over 1. And of course, we can keep doing that forever. So up 1 over 1. Up 1 over 1. Now, do you have to keep writing up 1 over 1? No. Once we have, actually, we only need 2 points to determine a line. To get it to work nice and straight in your rule, it's probably a better idea to put 3 or 4. But 2 points will give us our line, and all we have to do is start at 0, 0, up 1 over 1. So 1, 1 is on our line, and voila, there we have our graph. Okay, this time, we're starting at the origin again, and it's a little bit easier actually to see our rise for run because it's written as a fraction. Our rise, if we have a negative sign, we're going to let it be with the rise, and our run, we're always going to let it be positive. So this graph starts at the origin again, and it's going to go down 3 over 2, and keep repeating that pattern forever. I can do it backwards here. And sometimes on your graph paper, if they give you too small of a square, you may have to do it backwards too. So I went backwards 2, left 2, and up 3. But still, going from left to right, that would be down 3 over 2. All we have to do is take a straight edge and draw our line, and there it is. Okay, so summing up what we just did, direct variation equations are in the form y equals kx, where k cannot equal 0. The graph of y equals kx always passes through the origin, 0, 0. If slope can be positive, it's going to go up from left to right, and slope can be negative, it's going to go down from left to right.